Yes. So look at this chart. We have a mitigation. Has not been widely covered. So I think you all know very much about Chang'e 3, Chang'e 4, Chang'e 5, and next year we will launch Chang'e 6 sample return and Chang'e 7, 8, and 9 for International Lunar Research Station. So we heard a lot of lenders, commercial and governmental lenders. So many activities, we have to think about how to protect our lunar environment. So I will address on this radio frequency because on the far side of the moon is the most important, there's the most important environmental protection issue is the radio frequency. On the far side of the moon is so quiet. All the emissions from the Earth will be blocked by the moon. So there is the only place near our Earth we can observe the universe. So here is a chart of the universe as far as we understand. We can measure all the frequencies up to X-ray, but there's only one period of our history of our universe is called dark age. Because in this period, there's only natural hydrogen, no light, no photons. So, but how can we measure this? There's one signal coming out from natural hydrogen is the emission at 1.4 megahertz, because electrons rotate from right-hand side to left-hand side. So this emission, after so many years, is coming down to a frequency of this band, 1 megahertz to 30 megahertz. And this frequency is so much spoiled in our Earth environment. All the industrial noise and also the lightnings emit a lot in our atmosphere. So we have to go the far side of the moon. So there's a mission in China, it's called DSL, and it's measuring at this frequency using interferometries on the far side of the moon. So I will just show a less than 1 minute video of this. This is a constellation of a small satellite with one mother satellite, and the interferometry is measured between all these small satellites. And there's also one high frequency spectrometries. It's called high frequencies go up only to 150 megahertz. So after the launch, it will go to the lunar orbit, and in the lunar orbit, all the small satellites will be deployed from the mother satellite and forming interferometry baselines between them. Any two of them will form a baseline, and because of they are rotating about the moon, and the baseline also rotates. So it covers the UV plane completely. And you do a Fourier transform, you get the image. So we will be, hopefully we can get the image of the early universe dark age with this frequency. So we call protection of at the far side for radio quietness. So if you have lander on the far side, and the frequency is very limited to be used. Thank you very much.
Excellent. So thank you. Very complimentary.